guys, this is Wojtek, and today we're going to start looking at line traces, and specifically what we can do with them within our world, where we can place them, how we can trigger them, all that good stuff. So the LineTraceSingleByChannel is the first one we're going to tackle, and then we're going to examine its output type, which is the FHitResult, as well as we're going to leverage a couple of debug commands that the engine provides us, specifically the line and the box, to help us kind of see where things are happening in the world when we shoot out these lines. Lastly, we're going to look at this fmath function of VRandCone in order to help us create a bit of spread for our line traces, simulating a shotgun blast, because why not? It's kind of fun. So, let's get started. Alright guys, so let's get right into it. And we're going to begin by introducing a new action mapping for our fire event, or fire line trace event. And to do so, we're going to go to project settings, input, and under action mappings. Oops, that's too many. We're going to add a new one called fire line trace. And we're going to map this behavior to our F key. F for fire. Okay, cool. So we've got a button map. Now let's go back into C++ and actually start fleshing out this line trace function. So I'm going to begin by creating a new enum. And what this enum is going to allow us to do is flip between different line trace types through our blueprint rather than having to constantly recompile things off and on. So let's create a new blueprint enum within our player class. And this is going to be a enum class, eLineTraceType. And we're going to give it two types right now. So we're going to say camera single. And all this really is going to mean is that we are going to fire, so origin camera single trace. And we're going to do another one called player single. And you guessed it, this is going to be origin player, and it's also going to be a single trace. And this way we can keep growing these definitions as we add more types and behaviors. Okay, cool. So we have this guy, and now let's go ahead and actually leverage it within our player definition. So right in the public section, we're going to add a new property, and it's going to be eLineTraceType, and it's going to be called LineTraceType. And we're just going to decorate it as a U property, but rather than visible anywhere, we're going to say blueprint read only, and then we can only change the defaults. This is going to allow us to go into the player character blueprint and change this value to reflect how we want things to behave. Okay, cool. So we're also going to do another property, and this one's just going to be a float, and we're going to say line trace distance. Because we're generating this line, it needs a point of origin and point end, and whatever sort of distance between those 2 points is going to be. So again, we want to manipulate this as we see fit through our blueprint definitions. Okay, cool. So we've got these two properties. Now what? Well, we have our key bound, so let's also give it a function that it can attach itself to. So I'm going to call this guy fire line trace to stay in line with our action bindings. And I'm not going to do anything with this function outside of just making it a public one. Okay, so we've got our line trace distance, our line trace type, and now let's go ahead and start adding in these bindings. So I'm just conveniently located in our setUpPlayer input component method, and I'm going to create a new action binding. So bind action, fire line trace, and it's going to be on IE pressed. I'm going to pass ourselves in here, and then new player character, oops, fire line trace. Okay. So we have a bunch of stuff. Let's go ahead, because we added these new properties, also initialize them. So our line trace type is going to be, by default, camera single. And our line trace distance, by default, is going to be 100. Nice even number. Okay, so now let's go ahead and implement our fire line trace method. And I'm going to do it right below all these action ones, but before our logs. So we're going to say void are you player character fire line trace. Oops. Autocomplete doing too much. And there's our fire line trace function. So we're going to do just a warning function in this place. Okay. And the only other thing we're going to do before we start implementing all this stuff is comment out some of these other noisy little bits of information. I think I might have missed a couple. Here's our attacks. Oh, here we go. Attack start. And I put our line trace in the wrong location, so let's just move that up, or down rather. Get rid of these guys. Okay. Now let's drop in our line trace. Cool. So let's recompile and see what things look like. Okay, so with our project recompiled, let's take a look and see what's happening. So we got our guy here, and our kicks and stuff still work. Do they? Yeah, they do. Okay, so now when we hit F, we've got our fire line trace function working. Cool. Let's now start rendering this this line trace. And to do so, what we're going to do is we're going to go back to Visual Studio and into our fire line trace method. And right off the bat, we're going to do a little bit of logic. So what we're going to do is we're going to say if line trace type equals camera single, then do this stuff. Else if line trace type equals player single, then do this other bit of logic. Okay, great. So we have that in place. Let's now go ahead and start figuring out how to actually obtain the point of origin for our line. So what we're going to do is we're going to create two variables, and they're going to be vectors. Start and end. And these are going to be our starting and end positions for our line trace that we're going to fill in either with camera information or player information. So let's work on the camera bits first. So we're going to get the camera point of view, and we're going to do that by getting in the vector from the camera, so camera location, and we're going to have our follow camera, and we're going to get the component location. Oops. And the reason we're using follow camera is, if you recall, right where we define our player character, we are attaching a camera boom to him, and then onto that camera boom, the actual follow camera. So that's, if we go into our player blueprint, and there's our follow camera. So this guy right there. So what we're going to try to do is figure out how to get exactly kind of where this pivot point is, its center, so its location relative to the player. Or rather, its location as it pertains to what we're looking at, not necessarily to the player. Alright, enough jibber jabber. Let's go back into our actual fire function. So we're going to get the camera location. We're also going to get the F rotator, F rotator, and apparently I can't spell. And this is going to be also off the follow camera. Get component rotation. And now with these two values, we can determine our start and end positions. So we can say start is going to be our camera location. And then our end is going to be our camera location plus our camera rotation vector times our line trace distance. So we're going to go from the original point of the camera to wherever the camera is looking at in its correct orientation, plus whatever the distance is from the camera outwards. And it's going to be 100f in this case. So let's just put a comment on here so it's a little bit easier to remember. So this is going to be the ending location where the camera is facing based on the line trace distance. Okay, cool. So with these things in place, now we can go ahead and actually create our line trace definition. But before we do that, let's figure this stuff out for the player camera as well. And then we can flip between the two and see what it looks like. So we're going to do the same thing. We're going to create a vector for the location. So it's going to be player eyes location. And we're going to do a rotator for our player eyes rotation. All right, let's go rot. Just to stay consistent. And in previously defined variables. So we're going to use this accessor called get, and autocomplete's not behaving, get actor eyes viewpoint. And we're going to pass in the player eyes location and the player eyes rotation, as those are the two things that this method accepts. And what this little helper method does is it populates our vectors and our rotators with the correct orientation of what our player is currently looking at. So basically, from the point of view of his head/neck area, there's going to be an outwards line coming out to see where he's looking at. So if you can kind of guess the punchline to this exercise, by looking at where the camera is looking and getting the line trace out of that, we can determine things like first-person user interaction. And by getting the position of the player, we can do things like third-person interaction. So where is the player actually looking? Use that as a point of reference rather than the camera. We've got options, boys and girls. We've got options. Okay, so we get the location of our player. And now we can actually start going ahead and passing that into our start and end locations. So very simple. So again, the start is the end location, or sorry, the start is the player eyes location, and the end is our player location plus our player rotation vector times our line trace distance. Again, very similar to our camera. All right, cool. So we have start and end locations. Now let's actually draw this line trace. So the line trace returns a boolean, so is hit. And then we say from the world, line trace, oops, autocomplete's not working because that's misspelled. So now we say get world, line trace single by channel. And what this method is going to take is a handful of different parameters. And let's just close this off before we start filling them in. So what do they have? Let's take a look. So we take in the out hit, which is going to be a pass by reference FHitResult struct, and this is going to get filled up with all the things we hit when this execution occurs. It takes in our start parameter, it takes in our end parameter, it takes in a collision channel, and the collision channel determines what is it that I'm actually going to hit, what am I coming in as, and what objects do I interact with along the way. And then we've got some collision query parameters, so we can determine, how all that stuff sort of behaves. We've got some response collision parameters. Again, a little bit more nuanced details as how we can interact with those response objects. And that's about it. So let's now shove this into our definition. So our hit out is currently not available to us. So let's create this this definition. So it's an FHitResult, and we're just going to call this hit details and F hit result. And what does this constructor take? So it has a bunch of different sort of parameters you can pass in, but we don't actually care about this too much, so we're going to use the force init definition. And that just means it's going to force initialize this struct with some details. Okay, so let's start passing this in. So there is our hit details. Our next signature was our start. Our next parameter was the end. And then we have the actual channel that we want to interact with. And we'll just leave this blank for now. We'll come back to this in just a second. And then is something we're going to call trace params. And what trace params are, similar to our hit result, it's going to be another thing, another struct we defined based on collision query parameters. And we're going to call this trace params, fname text, and these are going to be our line trace parameters. So this is also going to take a true and a null value, and you can look into the definition of this struct for any sort of additional properties, but we're just going to go with these ones for now. So with our trace params, we can now do things like, hey, so we can say ensure that when you're doing the trace of our line trace, we're actually dealing with the complex collision of the objects we're interacting with. And again, you can turn this off or turn it on. You've got a lot of different options here. And the other one we're going to turn on is b return physical material equals true. And what this guy says is if we hit any physical materials, we can determine what type of material they are and then make decisions based on that material. And we'll get into this in subsequent videos when we look at things like footsteps. So depending on what I step on, I can use the physical material and a line trace to determine, hey, what sound should I play? You know, is it meant to be grassy, or is it meant to be rocky or metal sounding, or, you know, what have you. Cool. So we've got our trace parameters. We've got our hit details that we're going to populate. And we have some of this stuff, except for our collision channel. So let's take a look at our collisions real quick. So I'm just going back to the editor, settings, project settings, and collision. So in our last tutorials, we set up these weapon and enemy channels, but we don't really have anything for our interactions or our line traces. So what I'm going to do is I'm going to create a new object channel called LineTrace, and I'm going to make it ignore everything by default. So that way when it's added to all these other collision channels, it's just going to ignore it for now. And let's create a new collision channel profile. So it's going to be LineTrace and collision enabled. We'll just do query. Its type is going to be LineTrace. And now we can say, okay, so ignore everything except for the enemy. And we're only going to look at the enemy for right now. We can add some more stuff later, but we'll get into that. And then because our enemy by default is ignoring the line trace, we also need to ensure that it blocks it. And that way, when the collision happens between these two collision profiles, the line trace is actually going to register things correctly. Okay, cool. So we got collision set up. Let's go back to our code. We have a little bit of logic about flipping between different types. We've got our hit details, and we've got all this other stuff. So how do we now access what is essentially where were we? This channel by our line trace. Well, there's a couple of different ways. You can pass in a string reference of line trace and, kind of figure out how to organize that yourself. But there is also this value, ECC game trace channel 3, conveniently located. And what these guys are, if we look at them, is they represent the game channel definitions and some other physics channels as they pertain to all of these custom channel definitions you can add. And, it says, hey, you can add up to 18 of these presets. And sure enough, there's 18 of these guys. So we know it's the third one in the list that we're adding, this guy here. And we're just going to reference it by number 3. Now, you can create, sort of helper variables for all this stuff and constants and all that jazz, but we're not going to do that right now. We just know that it's the third one and everything is good. So let's recompile and see what actually is happening right now. And apparently I wasn't paying attention when I was typing, so I made a couple of corrections right here, and get world had a bit of a typo. So let's just recompile and try again. Okay, with our project recompiled, let's take a look at what happens when we now fire our collision, or our line trace rather. So let's go back to the project, go to play. There's our... And nothing is happening. And it's not that nothing is happening, it's just we don't have enough logic in our project to keep going and actually drawing this stuff out. So far so good. Nothing is blowing up, which is always a positive sign. But now let's actually get some details on the screen as to, well, what is happening? So we've got this boolean. So we can say if B is hit, then we can do something. So we're going to say we're going to say info, and we will say we hit something. And if we don't hit anything, oops, then we can say we hit nothing. Okay. And this is all fine and dandy if we want to see whether or not we actually interacted with something. But what about the line itself? Well, we know it's doing stuff. So there's a start, there's an end, a bunch of other stuff going on. But how do we actually visualize it? Well, the guys at Epic were kind enough to include something called DrawDebugLine. And the purpose of this method, as you can see by the signature, is to draw a line that's going to be rendered in the world based on a start and end location with some sort of color, and you can add in a bunch of other parameters like, hey, do I want to persist this line so it never goes away? If it does go away, how long does it become active? Depth, thickness of it, do I want a really big thick line or just a little thin skinny line? But let's make sure we actually draw stuff when things occur. So we can say start and end, and for the color we're going to use, let's do green for success. That seems positive. And we're not going to make this line persistent. We're actually going to make it live for about 5 seconds. And our depth priority is just going to be for static entities. And we're going to make it 1F, just a very thin line. Alright, so that's our success line. Now what about our failure line? And because I like the color purple, let's go with purple for failure. So we hit nothing, we hit something, and let's take a look. Okay, so with our project recompiled, let's take a look at the editor. There's our guy, there's a punch, and now, if I hit F, we're firing a little line and hitting nothing with it. And as you can see, the line is firing from our camera in 100 points outwards. So it doesn't even get past the character, but it does fire from the center of the camera. As you can see, that little dot, and then when I move the camera, it kind of rotates around. But it's only 100 units long, which, as you can see, it doesn't actually even reach the player. But let's see if we can... No, we can't. Okay, so let's go back to our third-person character blueprint and just extend the distance a bit. So rather than 100, let's do 1,000. And then you can see, because we have these cool little properties, we can actually flip between them accordingly. So, disregard the kick, but there's our line trace. And because we are using our line trace collision profile, as you can see, we know that this block is our enemy. Whereas these stairs and all of this other static stuff, the floor, you know, the air doesn't actually hit anything, but all of this stuff, it means we found nothing. But if we go back to our collision settings for our line trace, and let's say our line trace wants to also catch static objects. So we can say block static, and then if we go into our block all, we also want to make sure that line trace is blocked, because that's what our static elements tend to use, is just the block all. And then when we go back to our game, now when I hit the ground, hey, look, it's recognizing all that stuff. If I hit just the air, nothing's going on, except for these weird lines coming out of his crotch and butt, but that's okay. Now when we interact with stuff, we recognize these hits, and there's still our enemy. We can still punch it, we can still kick it, well, we can kick it, and then we can also interact with it. Very cool. But that's all fine and dandy for our camera. What about coming out of the player? So let's switch our enum and see what that looks like. So going back to our player character, we're going to change it from our camera to our player. And let's see what that looks like. Oh, and there's our kick. And now, as you can see, the line comes out of the player's head towards wherever we're looking at. So we can go, you know, upwards and downwards and all those good stuff. Create a little disco light show. But as you can see, it all originates from where the player is looking at. And this gives us just a little bit more flexibility and control over stuff. So our static objects are still connecting, our enemy's still connecting, the punches still work, everything's cool. But we now have the ability to flip between multiple different view modes, just simply by changing this enum type. Flip back to camera, and now we're originating our line traces from the camera point of view. Cool. So, what else can we do? Well, there's been a number of folks who have asked about, hey, it's great that you're doing melee stuff, but what about weapons? Well, you can use things like line traces to mimic the behaviors of weapons in order to simulate things like bullet spread. And I'm just going to show you real quick how you can go about doing that. But before we actually get into this, let's also take a look at, well, now that we're hitting stuff, what can we do with those hits? So going back to our source code, we're going to go down, to our fire function method. And over here, when we hit something, we can now take a look at our hit details. Well, what are the hit details? So they are constructed from this FHitResult. And if we pull up the FHitResult, you'll notice there's a pile of different properties for it. So whether it's a blocking hit, whether there's penetration that may be occurring, which face did we actually interact with of the object that we hit, the time, the distance traveled, because we're saying, hey, go out 1,000 points away from the point of origin, but if it hits something earlier, you'll get the distance. You get the location, the impact point, the normals, trace start, trace end, all of this other interesting stuff, like, hey, who did we hit? Which component on that thing did we hit? Was there a bone name? Or was there a bone involved in that hit? All kinds of interesting stuff. So we won't get into all these details. We'll be exploring them as we go along with our tutorials. But at a minimum, let's figure out who we hit, where we hit them, and perhaps do something with those details. So we've got our hit details, and we can say actor. So who do we hit? So I can say log hit actor, and then get the name of the actor we interacted with. And let's make this a warning as well. So there's our hit details for the actor. Now, in addition to that, what else can we look at? So let's look at info, or actually let's look at debug. And hit details, let's say, let's do the distance. So distance is just a float, so we'll have to convert it to a string. And maybe no, you know what? It's all good. And this will just be handled for us. No, it's not. Okay, and there is our sanitized float for the distance. Cool. Let's compile this and see what it looks like. All right, our project is recompiled, and we have a little bit of additional logging. Let's see what is happening with our player. Let's disregard that. And there's our hit. So we hit the linear stair static mesh, and that's the rough distance, 496, so it's about halfway of where we're expecting things to be. A little bit further out, and we move a little bit further out, there you go. But we're still hitting that static mesh. Now if we hit the wall, we can see it's wall 9, floor, we're not too close to that wall, that's wall 6, and what do we have here? There's our 1 meter cube. There is left arm static mesh, bump static mesh. So yeah, so we now have a little bit more information about the things we're interacting with. Okay, what else can we do? Well, we can start drawing some details on the locations that we actually hit. And similar to DrawDebugLine, Epic was kind enough to provide a DrawDebugBox. And what this guy takes in is the world, the center, the extent of the box, the color, whether it's persistent, and then the same sort of properties, the sizing, and all that stuff. So our world is going to be getWorld, and the center of our box is actually going to be the point of impact. So we look at hit details. We have things like get actor, get component, but then we also have impact normal, impact point. So if we get the impact point and we pass that in, all this guy is he's a vector, and then the extent of the impact is going to be f vector. I'm just going to create a new vector. 1.f, 1.f, 1.f. So it's going to be, actually, let's make it just a little bit bigger. And let's give it a color. So we're going to make these boxes when they hit. Let's make them blue. And we're not going to be passing in, any rotation. So I'll pass that as a null pointer. Actually, sorry, we don't need the rotation. We just need the color. We need the false for the persistent lines. We'll do again for 5 seconds, and this is going to be world static as well, and we'll say 1.f for the thickness. Okay, let's recompile and see what this looks like. Okay, so our project's recompiled. Let's take a look. So there's our guy, punches, but now when we throw our line traces, you can see there's little boxes being drawn roughly at the center of the impact point of wherever we connected. But you can also see, for example, if we shoot it over this way, that we have penetration. So we have the impact, the line trace keeps going, and then further, as it goes through our objects, it could potentially interact with others. So as you can see, this is now a great opportunity for introduction of things like bullet penetration. So if you have a gun and you aiming it at a wall, you can now figure out, okay, well, I went through this wall, but my thing still keeps going. Did it hit anything else along the way? And if so, you can do things like reduce the bullet velocity and the bullet strength and the, sort of the curvature of the bullet, all that good stuff. Cool. So we're going from our camera outwards. We can also go from our player outwards. Now, let's just add in that little bit of scattering to simulate just a different weapon and how our line trace could help us determine those impact points. So, to do so, what we're going to do is we're going to go back to our player character, and we're going to add a new property, and this guy's going to be called float line trace spread. Because earlier I was saying, hey, a couple of folks were asking about things like weapons, projectile weapons specifically. So let's see if we can use the spread to simulate a shotgun blast. And then we'll have it going out from the camera as well as the player. So let's add a few more enums to our line trace type. So we're going to have a new one called camera spread. And, oops, as you can guess, this is going to be similar to our single, but it's just going to spread out. And then we're also going to do a player spread. Oh my goodness. Apparently I can't navigate text words correctly anymore. Spread. Cool. Now let's get rid of this extra comma there. So now we have a couple of different line trace types that we can do some more work with. So let's go back to our CPP file, and wherever we hit stuff now, or rather wherever we execute the firing, we now need to do just a little bit of extra logic to handle the spread definition. Now, we'll get into all of these other sort of helper functions that allow us to manipulate vectors and quaternions and rotators and all that stuff in the future. But at a minimum, let's examine how we can introduce spread. And we can do that by adding in a little bit of logic right here when we generate the end value. Because our start's going to remain the same, right? We want to start our projectile from wherever we're facing, be it the camera or the player or whatever other point of origin, let's say the current position of the barrel of the thing you're actually aiming with. So let's say if line trace type equals, and because we're working in the camera area, let's do camera spread, and we'll do a bunch of logic here. So we also need to get in here if we are dealing with camera spread. Okay, so if camera single or spread, if spread, do something, otherwise we can just do this, because we already have this logic figured out. Cool. So now how do we get the end with a spread? So camera location is still going to be pertinent to this, but now we're going to use this other thing called fmath VRandCone. And what this little helper function does is it basically says, hey, take in your vector and then figure out within a cone shape. So if you can imagine the outward line going from our camera and the ending of that line be contained within a cone, so a slightly larger area than the start. And what we're basically saying is, give me a random position within angles of degrees of this cone from my start to my end. So we pass in our end vector, our camera rotation vector as the input. And then we need to figure out, well, what is this cone or horizontal or vertical cone half length? Because I can either sort of have a generic one, or I can have one for the horizontal movement as well as the vertical movement. So I can have, let's say, my bullets spread upwards, but not side to side. So we've got a couple of different options, but let's use the same one for this exercise. So let's create a const, which is going to be our spread. And because we know this VRandCone expects radians as input, radians in the form of a float data type, we need to convert our degrees to radians. And look at that, there's a function for it. So it takes in our degrees, and our degrees are our line trace spread times 0.5 f, and there's our spread. And you can configure sort of this definition as much as you want. If you want to go wider, you want to go more narrow, or what have you. But let's go with this for now. So we're going to pass this guy to both the horizontal and the vertical path. So that way they spread uniformly within our cone based on our camera vector. So cool. So we have our definition, and then the only other thing we need to do is multiply it by our line trace distance. Same way we're doing right here. So start plus randomized cone area plus our distance gives us a nice little bit of spread when we fire from a single location. Cool. Let's do the same thing for the player. So if line trace type equals player spread, do something, otherwise do this stuff. And we can put the start before that. Okay, cool. So we can do the exact same thing now with our player start. So our location is the beginning. Oops. Our location is the beginning, and then the rotation of the player eyes is where we're going to apply our randomized cone definition. Okay, so let's recompile and see what this looks like. Alright guys, so the project's recompiled. Let's see what our spread looks like now. There's our guy. And there is a single line being fired, and there's no spread. It's just me moving the camera. See, if I remain stationary and just hit it a bunch of times, it all comes out from a single spot. So let's change that. Let's go back into our player character blueprint, and let's say camera spread instead of camera single line. So there's our guy. Now, when we fire, bam, from the camera, they're spread. So this is the sort of stuff you can now use using our line trace to do things like shotgun spreads. That's pretty cool. And let's go ahead and now try this from the player. And unfortunately, that guy's not firing because in our in our player conditional, we forgot to say LineTraceType equals player spread. Cool. The other thing we forgot to do is just initialize our spread definition. So by default, let's say it's 10 degrees. Okay, let's recompile and just double check that our last trace spread is working correctly. Okay, project is recompiled, and let's just double check. Okay, so that's spread. There's our default 10 for our player character. And let's start this guy up. There's our gameplay. And now, bam, look at that. When we fire from his face, it looks like a nice little shotgun blast. So you can see now, with just a little bit of effort, how easily you can modify some of these default tools and tweak them to your needs. And we'll be working with line traces a little bit more, as well as the debug lines and boxes and spheres and all that good stuff in our upcoming tutorials. So thank you for tuning in, and I hope to see you guys next time. This is a little PS for anyone that's still watching, because it came to mind right after I was done recording, but we can also, by including the tick method, constantly fire this line trace. And this is really good for things like, hey, I need to be able to detect what I'm looking at and then make some operations based on that thing that I just found. So, to do so, what you can do is go back to the player character header file. And what we're going to do is actually right in the public section, where we already have a virtual override for begin play, we're going to do another one for the tick. So virtual void tick, and it takes in a float delta time override. So now we can go ahead and implement this method, and then within it we're just going to call super tick delta time, and now we can say fire line trace. Let's recompile and see what this looks like. Okay, we're all recompiled. Let's go back to our game. And let's go ahead and, rather than using the spread, let's do player single line. And that way, we're going to get a feeling for what this looks like when we look. There you go. This is what happens when we include the line trace in the tick. You are constantly evaluating everything around you. And you can see all the little impact points as we touch stuff. And this is a really easy and good technique to use for things like object detection. So, hey, I'm looking at this box, now I can make some operations on that. But yeah, there you go, guys. Not a lot of code changes, just a little bit of replacement of our fire line trace function. Plus, you can also do these weird little light shows for my own personal amusement. There we go. Look at that. That's a nice red mess. But it'll go away. Okay, thanks guys, and hope to see you next time.